Hello. So I guess we've heard a lot about DDS and security today, so I'm going to put these two things together a little bit. And I'll give you a little bit an overview of how DDS fits, especially with security. And hopefully there will be, that won't answer all the questions. It's a pretty broad subject. And the good news is there is a whole tutorial on ROS next week on Monday, so you can find more there. But anyway, so I think what I wanted to cover is a little bit an introduction to the concepts of DDS security, a little bit I give an idea of how it impacts performance of a system, and then how, because ROS, as you know, kind of uses DDS, but it kind of adds its own sort of sauce on top of it, and those mappings kind of impact a little bit the kinds of things that you can do with the underlying concepts in DDS security or not. And those are, of course, evolving, so I think it's good for people to be aware. And then give you a little bit of a concept of how do you, today, what kind of tools do you have to use DDS security with ROS, and generally to use security with ROS, which is what otherwise is also known as SROS. So as a background, I want to also kind of broaden your perspective about what DDS really is. I mean, this is the set of specifications that currently fall under the family of DDS specifications. You are mostly interested when you talk about DDS. You typically are going to be concerned with the wire protocol because this is the thing that shows up in the wire. You're also not really easily seeing these APIs because these are sort of hidden behind the ROS client layer and the ROS middleware wrapper. But you kind of, the kinds of things that you can do are defined in those kinds of specifications that talk about the qualities of service and so forth. Then DDS security is the thing that you're going to finally deal with when it comes down to the authentication between the different ROS nodes and the permissions and how all those things are enforced. And then the type systems, that comes from the DDS text types specification, and that gets mapped to the ROS message types and so forth. But again, the kinds of things that you're going to be able to do there are going to be, to some extent, controlled by that. And then this DDS XRCA specification is showing up now as a gateway specification. I think you've heard of micro ROS, not my favorite name for that, but it actually does the gateway between the RTPS or RTPS specification and the XRCA specification that gets you access from a very small footprint node. So, and this has been evolving over a number of years, so it's a pretty long thing of things there. But so if you want to go learn more details about any of those things, you can go and download the specifications from the object management group. So with DDS, it has the concept of topics and publish subscribe, very much like ROS. There is a little bit of a twist in the way DDS uses topics, in that for DDS, a topic is actually a collection of data objects like this. So you have a number of cards, for example, or publishing on a single topic called card position. And the fact that it's one card versus another, that would be identified by certain fields inside the topics called the key. Now, when that gets mapped to ROS, actually the current mapping of DDS to ROS, or the ROS to DDS, is not using keys. And what is happening is that those identifications of the different cards will end up showing as the topic name. So the implication of that is that whereas in DDS you would be able to have a single writer entity published for many different objects, like you could be publishing for all the cards, like if you were a simulator with a single object, or you would be able to subscribe to all the cards. When you're going through the ROS middleware layer, you're going to have to create a different publisher or subscriber for each one of those objects, right? Now, in DDS, there is also the concept of quality of service, which maps what you are able to produce at the data writer level with what you are able to consume. With ROS, that gets exposed by means of, I think they call it profiles, QS profiles, and they've selected like 3 or 4 essential qualities of services. I think durability, reliability are the 2 main ones that come to mind. The other ones are still there, but you would have to go to sort of to the underlying DDS mechanisms to configure them. You wouldn't be able to just do that from the ROS layer. And there is also another concept of partitions, which is also not currently exposed to as far as I know, from the ROS client API. That is something that allows you to, even within a single topic name, to kind of isolate different planes and say all these group group of applications are going to be talking independent of this other group of applications. You could have them running on the same set of nodes or activate or deactivate, like simulation versus a live system and so forth. So the reason why I mentioned that is because some of the things that appear in DDS security enable you to sort of separately give access control and permissions to this one of those things. So if you wanted to take advantage of these capabilities, then you would have to sort of find a way to get partitions configured into the ROS client layer. So yes, I won't go into more detail. I want to get into the main point of the presentation, which is DDS security. And the first thing I want to talk about is that security is actually sort of there is many layers to security, and you cannot just do layer at any one. You cannot just do security in any one layer. You have to do it at all the layers, right? So, and it was mentioned before that you kind of have to protect the integrity of your nodes and the key material that you have, and the integrity of the configuration files and the libraries and so forth, which would fall under the host-based protection and boot boot attestation and all kinds of techniques, which are important for you, but it's not something that DDS kind of deals with. And also, there is the issue of access control to the whole network, which typically gets done through some kind of VPN technology. That's also something that you would probably want to do if you're concerned about security, but again, this happens under DDS and under ROS, right? So you're running an encrypted line, and everybody has to have some special key or something to join it. That's fine. And that's a good practice, because before the question was asked about denial of service attacks. I mean, that's a very difficult question. I mean, they are really very hard to protect, and you kind of have to have several layers of defense to kind of make them harder and harder. And one of the layers of defense that you're basically preventing access to your shared media, which is your network, right? And only few people can get in there, and then you start looking at deeper and deeper protection against that. But finally, what DDS is actually trying to do is protect the data itself. So once you are inside the network, what DDS is trying to do is to say it's not a binary thing being inside the network or being outside the network. Inside the network, anybody that has anything to produce any node needs to have some identity. It needs to authenticate with other nodes to prove who they are. It needs to show that it has the necessary permissions for every single message it writes, or every single topic, I should say, it writes or it reads, or every single service it invokes. Is not going to be able to do that just with the global permission of being able to join the network, right? And that's very important, because escalation of privileges is one of the most sort of subtle attacks where an application that has permissions to do something is supposed to do something very narrow, all of a sudden gets hacked through some vulnerability, and because there is not enough granularity in the access control, all of a sudden it can do everything that it shouldn't be doing, like the classic Jeep driving off the highway attack because the Bluetooth tire sensor was hacked and it was all of a sudden steering the vehicle. That should never happen if you have fine-grained control and you were able to tell the pressure sensor in the wheel that the only thing that it can publish is pressure sensor, pressure value, right? It's not able to publish a steering command or brake commands, right? So that's why granularity is very important, and that's really what DDS security does, and that's what ROS security leverages on top of DDS. Right? So when you look at that picture, what really happens is that all those topics that are in the shared global data space become individually protected. And become individually protected means they have to be separable, right? So you cannot give differential permissions for somebody to read or write if you use the same key, because if I use the same key for two topics and I give you the key to read topic 1, all of a sudden you're going to also be able to read topic 2 just by snooping the network. And more subtle is, how do I protect the permission of read versus writing, right? Because if I give you the key to read my topic that I'm publishing, what prevents you from all of a sudden encrypting and signing that data with that same key that I'm using, right? And I'll cover that because that's a subtle thing, but it's actually very important. If you have a system where it's important to separate the permission to read something from the permission to write something, you need to take advantage of this technique that I will talk about later. So in DDS, basically, it's an add-on to the DDS specification. It defines a set of plugin sort of components that fit into the DDS stack. So when the DDS is going through several decisions, like it discovers a participant, which is a node in the case of ROS, it discovers a writer or a reader, it discovers a participant, authenticates, it discovers a writer and reader, it checks whether it has permissions to read and write the topics. If it has permissions, then it shares the necessary keys from the writer to the reader and so forth. Now, the reason why it's important that these things are pluggable is because you may encounter that the built-in plugins are not sufficient for your needs, and then you have an opportunity to build your own custom plugins, and because those APIs are standards, you will be able to plug those into the different DDS implementations that go under ROS, right? So as long as those implementations support the DDS security and are complying with those interface specifications, then you can plug in a different access control or a different key distribution algorithm or cryptographic algorithm and so forth. So how is all configured? So from the DDS point of view, and this is for the built-in plugins, because if you plug a different set of plugins, then you can do things totally differently. But from the DDS point of view, it comes down to having some agreed authorities that all the nodes on the network are going to say, yes, we agree that these people are the people that are sort of giving permissions and giving identities to the network. And you can specify two separate authorities, although you could also make those two the same authority. But there is an authority that identifies, it gives identities, and basically says, hey, this name is a public key, and a subject name is valid. It has a valid name that I'm signing, right? And there is another authority that basically attaches a set of permissions to one of those identities, right? So it says, well, the subject name, maybe the subject name is the name of the fully qualified name of your ROS node or the ROS application. Well, this ROS application has permission to write topic A, topic B, and topic C, and is permission to read topic D and topic E, right? So, and that gets done through essentially a set of signed documents. So you get those identities, authorities are signing documents for each application separately, and those applications carry those documents as sort of their proof. Like imagine you have your passport. Passport is issued by an identity authority, which is the country, right? And then it has permissions associated with it, which basically says it allows you to cross the border, right? So the border authority, which is the one that decides who can get into a country or out of a country, accepts a passport as a proof of permission to enter the country or not. But a bank could also accept the passport as a proof of permission to open a bank account, for example. And then there is another document that basically describes sort of what are the rules for a specific distributed application, because again, since it's not an all or nothing type of situation, you could say that certain topics need to be protected, some other topics could be open, don't need encryption, and there's different kinds of cryptographic techniques you can use. You can totally encrypt the topics, or you can just use message authentication codes, which are more efficient, that prevent tampering, but don't actually encrypt the data, so are much faster to do. So in the end, what happens here? What happens is, applications appear. When the application appears, they exchange discovery information. Then these plugins come in and say, I've discovered this participant, is this node, is trying to join the network. Let me check that it has a valid identity certificate. If I check it that it's signed by the authority I recognize, then I challenge to prove that it has the private key associated with that certificate using the standard PKI techniques that you would use in TLS or you would use in HTTPS. That participant responds to my one-time challenge. Likewise, I respond to his likewise challenge, so we establish mutual authentication. As part of this process, we also establish a sort of a shared secret that we can use to exchange secret information, and we use that sort of secret channel to exchange key material. Because then the next thing that happens is I will discover some readers and some writers, something that he's publishing and subscribing, and if he's subscribing to something I'm publishing, and he's showing me a permissions document that says that he can subscribe to that, then I will send the key material I have for that particular topic. And I will use that sort of secret key exchange key that I've established during initial authentication, which is unique for each one of pairwise of nodes that get discovered. So all that happens automatically inside the DDS security, so you don't have to worry about storing those keys, creating those keys, or undoing any of those things. Those happen automatically as a side effect of creating writers and readers. So those documents that define the permissions and define the governance, in the end, they're XML files that have a standard format. Typically, you're not going to interact with this because, as we will see later, ROS provides a set of tools that automatically generate those documents from some sort of higher level description of your ROS kind of nodes and topologies. but it's at some point you start trying to figure out, okay, what's not going with my system? Why am I getting this error like you saw in the presentation this morning? Some messages saying, oh, this thing cannot come through, it's not allowed. And you see this topic is not allowed. Well, the topic that's going to show you there is the DDS topic that couldn't be created or couldn't be authorized. And then you're going to have to a little bit understand where those come from. And those documents, they are the ones that are used to configure DDS, so you will be able to see them because they have to be provided to your application, even if you don't create them directly yourself. Okay, so one of the permissions document looks pretty simple. It has an identity, so each one of these documents would be for a single node, although you could combine many nodes within the same document. It has a subject name, so that would be the thing that ties to the public identity in the identity certificate. And then it has basically things that says, for this domain ID, you can publish these topics, and you subscribe to these topics, and you can have expressions for topic names, so you can have, all the, like if the way ROS maps topics for nodes, they start all with the same prefix with the node name and the namespace, so you could just put a star and say anything under the namespace is something that this node is allowed to publish, for example. There is another subtle thing, which is the concept of data tags. Data tags are a way to associate metadata with publishers and subscribers, which is not, and that is authenticated by the DDS security, but is not interpreted. So the reason to have that is because sometimes you need to build your own custom sort of access controls and policies, and this gives you a hook to very conveniently do that. So I have an example of how you would do that. For example, imagine that I'm trying to build an air traffic control system. And for me, it's important to know what the different airlines are, and a certain aircraft, because it belongs to a company like Iberia, is only allowed to publish locations for Iberia aircraft, right? So one way I could do that is to basically, of course, I could have different topic names, but that would force me to have different consumers as an air traffic controller for each one of the aircraft. So if I wanted to use the same topic, one thing I can do is sort of attach the carrier name as a data tag to my data writer. And what DDS security will do, it will say, you cannot attach that data tag unless you have that permission on your permissions file. So you are only able to publish that if you have the permission authority has given you explicit permission to attach aircraft name Iberia. So that will be all authenticated and checked by the middleware. So as a consumer, when you get a piece of data, you can look at the content of the data, and you can see what the aircraft flight number is, and it will say Iberia 97. At that point, you could say, okay, is Iberia, does the data writer that sent me the data have the tag for Iberia, right? That DDS is not going to do for you because it doesn't understand that the content of the data is supposed to correlate to some tag. But you at the application level or the robotic client library could go and look at that and say, okay, I'm going to use that to restrict and attach that kind of behavior, right? So it's not, and if somebody, for example, had a data tag for Air France and was trying to publish Iberia, then at the discovery time, if it tries to attach the wrong tag, it won't be allowed to join. And if it's allowed to join because it puts its own tag, when it publishes data for the wrong airline, then the receiver will look at it and say, okay, you don't have the tag that allows you to do that, so it will reject that. So, okay, so I want to give a little bit of an idea of performance, and I'll start saying that performance is a real hard problem. It's very hard not to know that you are comparing the right thing. And I know there are presentation of performance, so this is not about really performance. What I'm trying to accomplish here is just give you sort of a relative feel for how expensive it is to use security. So don't look at it as absolute numbers, right? Look at it as relative numbers, right? Another thing is that it's multidimensional, right? You could start looking at, well, what is really performance? It depends on the quality of service, depends on the scalability, depends on the data size, depends on so many things, right? So it's not an easy solution, right? But I want to talk about that because encryption and protection is also multidimensional. You can basically, at the application level, when you write data, you could be encrypting the data. But then when you put that data on the wire, you could also be encrypting the wire. Like when you use TLS or DTLS, you would be doing that type of thing, right? And depending on how many of those encryptions you do, you can get different characteristics. And DDS actually offers some unique properties there that actually end up being very helpful for performance. But you won't see that benefit if you are testing a single producer to a single consumer, right? Because that's a very simple case where either way you're only going to do one encryption. You will only see that benefit when you go into more complex scenarios with multi-producers and consumers. So typically, when a message gets written on the wire, you've got essentially data and data is what your application writes that gets serialized. And if it goes through a process of encryption, that data is going to be encrypted, and then you're going to have some headers and footers, message authentication codes that protect that. But when the data gets put on the wire, that whole message itself can also be wrapped, right? So that's what's called the message protection or RTPS protection that doesn't really care about individual data. It cares about the whole message, and that's kind of more of a transport level type protection. And typically, people are going to combine those two types of things because one of them is going to protect the contents of the data, and the other one is going to protect things like sequence numbers and sort of protocol level type details. And so going back to the original question, how do you separate protection from reading versus writing? So the only way to protect and separate the permissions to read or write is that a reader needs to get some unique piece of information from the writer that nobody else has, only the writer has, right? So if the reader shares something in common with the writer that the other readers don't know, then the reader can check that that unique piece of information that gets used in some kind of signature came from that particular writer. So the way DDS does that is by using this kind of multi-message authentication code. And we call that origin authentication. And the way it works is that when you've got a piece of data, or it could be the whole RTPS message, first of all, this thing goes through the cryptographic mechanism where it gets encrypted and then signed with what is called a common MAC, common message authentication code that is shared with all the authorized readers for this message. But then it follows that with a set of receiver-specific authentication codes. Each one of these authentication codes is basically signing this. It's not signing the whole thing. It's signing the previous MAC. But it's signed that with a key that is shared only with one reader. So the receiver A will be looking for this signature, and the receiver B will be looking for this signature, and the receiver C will be looking for that signature. So then it's impossible so if I'm receiver 3 and I'm looking for this signature, nobody else other than the sender could actually put that signature because the sender only shared that secret key with the receiver 3, right? That's why it had to share different keys with each one of the receivers. So that adds a little bit of payload, right? But it adds like 128 bytes of payload to every, or 128 bits, sorry, of payload to every message per receiver. It's much more efficient than sending the whole message again with a different key, like something like TLS or something would do. So in the end, you can see here what happens with DDS security versus other technologies. If you use a classic transport level security, the data gets encrypted as it goes to the transport. So you write a piece of information, it goes to 3 consumers, it's going to be encrypted and signed 3 times, right? That's the top level. If you use DDS security, the data is going to be encrypted just once. And then if it goes over unicast, it may be sent 3 times, but it's going to be exactly the same message that gets sent 3 times. So that's a lot more efficient. If on top of that you have multicast, then you're actually only going to put it on the wire once, and the network is going to go 3 places. Combine that with origin authentication, you are not losing the ability to know that the message came from the actual writer and not the other thing. So you can see how that can be a lot more efficient than doing something like transport level security. So now to the numbers of what the performance looks like. So I've taken some numbers here, and you can look at the presentation later in more detail. But the bottom line, so I've scanning from 32 bytes to 1 megabyte, different configuration from no security, which will be the baseline, just signing the message, that's a message authentication code, encrypt the message and sign it, or encrypt the data and sign the overall message, or encrypt the data, sign the overall message, and add an origin authentication. You can see what the cost is. And you can see that the origin authentication, well, this is a one-to-one case, doesn't really add any cost. But we will see in other slides what is for other ones. But you get the rough idea that it's going to be somewhere between 1 to 25% or to 40% overhead, depending on the message size. Of course, for small messages, it's a lot more expensive because the encryption is block side, so it's going to add a payload on that. And this is the throughput. And again, you can see that is not a whole significant degradation on the throughput through the different kind of cryptographic techniques. I have some other slides where you can actually look what happens when you go from 1 to 4 consumers, for example, and you can see, and this is using multicast, it's all reliable. You can see a little bit of degradation because of the reliability, because of the reliability that causes like essentially the sender to throttle to the slowest consumer, but you can see that it's not like, you don't get half the performance when you go to 2 and a quarter performance when you go to 4, right? So I want to talk a little bit about ROS on DDS with the remaining 5 minutes. So the way ROS maps to DDS, basically, there's a lot of similar concepts. The publishers have data writers in DDS, subscribers have data readers, QoS profiles, and so forth. And there is a little bit of a mapping when it comes down to the names. So where the ROS service name gets eventually mapped to a topic name, it gets prefixed with some things, it gets put into a namespace and so forth. So that's why these tools help you really not having to know all those things and be able to get the right artifacts for the DDS configured. So maybe I'll give you the rest of the time.
Okay. So I don't have much more time, but what's good about this is you can come to the ROS2 tutorial at IROS Monday to figure out more. And so basically we're going to talk about, give an introduction to the tooling, the current infrastructure, so what the ROS2 security commands do, some of the works I've been doing on keymint. So here's an example of what's the minimal policy look like for a talker. And so you need to allow to publish a chatter, you need to allow access to the clock, you need access to all these other parameter services. And so some of the other stuff I've been working on is more expressive policy syntax and how you can compress this into more of a modular composition of something that you could do static analysis on. So here we have an equivalent definition of a profile that you can label. You can have multiple attachments to bind the same policy to multiple subjects, and then also have multiple objects with the maybe common permissions, and then also use nested imports like you would have like any kind of programming language to redefine common attributes among certain elements of your policy. That way you can be more sure of your policy definition and how you verify it as a small component of modular parts. Some current aspects of SROS. So we know that we can ensure node authentication with domains, topics, services. Parameters are currently on the granularity of nodes. We're working on new ways to kind of address that. So that's another key point of the security meetup we're going to have tomorrow at lunch, as well as during the ROSCon, or the IROS tutorial. Current weak points right now, like I said, not everything is exposed during in the SROS interface. But that's to be expected because DDS expands so much wider. And maybe some closing points.
Still 2 minutes. So yeah, thanks. So basically what I want you to leave understanding here is basically that so it's a good foundation for what SROS is trying to do, the capabilities the DDS provides. Obviously there is more things there, and some of them, if they are useful to ROS, they will emerge. But when it comes down to the plumbing, what kind of cryptographic techniques is used? Is it scalable? Is it high performance? We're basically using best-of-class techniques with AES and elliptic curve and so forth, Diffie-Hellman for authentication, for shared key establishment. It's very important to know about all this fine granularity. I think this is one of the things that is typically overlooked in security. So being able to really control access at the finest possible level, and also control how much you want to spend. Like maybe for some data you don't need to encrypt it. Authentication is sufficient because you just need to prevent from tampering, right? So to have the ability to set that is quite important. And also to know that if you don't find what you need there, then you can build your own plugins. That's also a pretty good thing to know. Another nice thing about the way it works is that it's transport independent. So if you decide to deploy this over shared memory, for example, and some of the DDS implementations out there support shared memory, you don't have to change anything. It still works because it's not trying to take advantage of something like TLS that is baked into the transport. And finally, and this is very good, it's just a set of configuration files. So you can build your application without security, and then you use the tools to create the security artifacts that you need, and then you basically run them enabling security, certain environment variables, and then all of a sudden it's all secure, so you don't have to change anything. So that's what I had. Thank you.
We have time for one question if anyone in the audience has one. Otherwise, I'll start you off. Can you give an overview for people who are looking to use DDS security, ROS2 users? Is that available out of the box, or is there something special that they have to do?
Currently, security is released with ROS2 Bouncy. So they can use the SROS tool that is shipped to try out the demo Talker example. So you basically have all you need. What we're working on is to simplify the user experience, so it's harder to shoot yourself in the foot, and as well as expand the feature set so we can take more advantage of the feature parity in DDS.
Thank you very much.